So box plots, can read through. I already started reading through that. Just a sec here. I started trying to download Google Meet on my phone, and then it came back up. Then it uses data anyway. Okay, so box plots. So remember we talked about if you have a whole list of data, median is the middle value, lower quartile is the median of the lower. I guess that would be when you're looking at me this way to your left, and quartile 3 would be the median of the upper. Sometimes the median is denoted by Q2 because if you look at Q1, Q2, Q3, all right. So each quartile represents 25% of the data, or approximately, depending on if there's an even number or an odd number, that kind of thing. Okay, so to construct what's called a box plot, we need 5 different, that's right, yeah, we need those 5 values that are listed there. Okay, sorry, I'm going to share this. All right, so we need the 5 values that are listed, and so we're going to do it for question number 1 here. Should be, yeah, you should be able to see the screen now. Oh, I just want to close that. Okay, so actually maybe I didn't want to do that. Just a sec, let's see. Anyway, you've got your data there. It says, given the following set of marks for a math class, determine the lower extreme, upper extreme, median, first quartile, and third quartile. Yeah, you could enter all of that in your calculator and get it to do it, but we're going to do this one by hand because it's not like the mean where you have to add them all up. And notice how they are in order. So, first of all, how many data values are there? So there's 7 in each row, and there are 5 rows. So 35 data values. All right, so 35 values. So if we want to think about the median, so we want to find the middle value. So if you divide 35 by 2, you get what, 17.5? So it's going to be the 18th data value. So that you have 17 in your list, 17 is 34, and there your median is in the middle. So we want to look for the 18th data value. These are in order. So there's 7 in the first row, another 7 is 14, 15, 16, 17, 18. It's smack dab in the middle of it. You know, that kind of makes sense, right? Median. So median is 71. Then we want to find the median. So that's the middle value. Now we're looking at these 17 values, okay, and finding the median of those. So 17 divided by 2 is 8.5, so it's going to be the 9th data value. So there's 7 in the first row, 8, 9. So that's going to be your first quartile. And then 9 from the end. 7, 8, 9 from the end. Your lower extreme is your lowest value. Your upper extreme is your highest value. So, what makes a box and whisker plot? Okay, well, there's directions down here on how to construct it. I'm just going to show you. You plot, so basically you do one number line that has at least the values from the lower extreme to the upper extreme. It should include values that make sense for the information. So in this case, this is a set of marks for a class, so it's the percents on a test. So it could be possible data values could be between 0 and 100. So that's why they're all plotted on the number line. Now, do you always have to do that? No, you just need to make sure you have at least the data values, all right? But it's nice to represent what possible values a situation can have. There's no y-axis. So important to use a straight edge, okay, not a squiggly line. And so above that number line, you do an equal scale, first of all. So not just randomly marking. Get a ruler out, equal scale if you need to. And then your lowest value is 35. So above, somewhere above, you put your first point. Then get a straight edge out and follow along and draw a line to your first quartile. Then don't draw a line, but draw a point at your median. Don't draw a line, but draw a point. So you can keep your ruler there, right? At your third quartile. Then draw a line to your upper extreme. Okay? Then just move your ruler below from this to draw a rectangle, a box, basically, and above. And then a line through the median. Okay? So, and then these you joined up with your ruler as you went. Oops, because you had a ruler there. Okay? And so what we're looking at here, it's kind of a nice way of thinking about the percent of data values. So that this represents 50% of the data, right? The middle 50%. This represents 50% of the data, and so does this, right? This represents 25%. So basically between every dot is 25% of the data. So any dots that are close together means the data values are close together, right? So these data values, this 25% of the data values are much more spread out than this set, or even this one, or this one, any of them, right? And that's often the case when we're talking about tests. Okay. Usually they're more concentrated around the median. And then the whisker, so this is the box part. This is box. Sometimes they're called box and whisker plots. These are the whiskers. Like your cat has whiskers, right? Okay. So there's directions there on how to do it. So each section of the box, at the very bottom, it says each section of the box plot, the left whisker, the left section of the box, the right section of the box, and the right whisker each make up 25% of the data. That's what I just talked about. Okay, so in any box plot, what percent of the data are below the median? So remember that. Median splits it into 50%. Below the first or lower quartile, that's 25%. Above the first or lower quartile, well, that would be 100 minus 25 is 75%. In the box, the number is 50%. Each whisker is 25%. And below the third or upper quartile would be 75%. Okay. Give me a sec to get caught up on that. So now we're going to draw one ourselves. So it says information about the results of another exam are as follows. So the lower extreme is 45. The number line's already given to you. So above 45 with a dot. First quartile is 56. So again, you're kind of estimating a little bit. Then median is 70. And 76. And then 87. Okay. So now what I would do, I don't have a ruler, but I have sort of this line that I can do. So I join these up. I need to lower that a little bit. Join these up. Okay. Then below, I'm going to draw that. And above, that. Okay, and then I'm going to just fix that a little bit if I can. little bit more even. This one. Okay, so then just drawing the verticals. This, that's better, and this, all right, a little bit crooked. There we go. Okay. All right, so that's our box and whisker for that one. Then it says another class is given here. Okay, so another box and whisker. And then it says complete the table for this one. So now our lower extreme, we look and approximate, that looks like about 30. First quartile looks like 50. Median looks like 65. Third quartile looks like 85. And upper looks like 100. Pretty straightforward to copy those out. Okay. So taking a look just in terms of analyzing these, the median in this exam was lower than this class. So same exam, this median was lower than this one. Okay, but if you take a look, these marks were all above 45. So these ones were not. These were above 30. Okay. So, you know, different things. Obviously, this is way more spread out than these ones. So this class are more, the first class here is more, I guess you'd say homogeneous. That means they are more similar. Okay, their marks are closer together. This one, they're all ranges from 30% to 100%. Okay. All right, so it says use the TI calculator to find the median, lower, and upper quartiles for the data presented in the following frequency table. Draw the box plot and determine the interquartile range. Okay, so there's your calculator. Notice here that our chart, really we did it horizontally. We gave it to you rather than vertically, just to save space. So you go to Stat and Edit on your list. Now I still have the list up from yesterday, so I'm going to cursor up and press Clear, Enter. Cursor over, cursor up, Clear, Enter. Don't press Delete because you'll delete a list and then you'll have to insert it back in. Okay. Now, my X values you always want to put in the first column, your data values, and your frequency in the second. You could do it the other way around, but then you have to tell the calculator L2 and then L1. So it's better to put your data values in the first column over 4 of those, 8 of those, 13 of those, 20 of those, 28 of those, 5, 13, 15, and 8. Okay. All right, so remember from yesterday, so quit out of that, and then we're going to calculate something. So stat, calculate, one variable stats. We never do 2 variables. I still have in my list from yesterday, in my one variable, L1 and L2. So leave it like that. If you have an older calculator, then you do your one variable stats, and you type in L1, comma, L2. Okay. And enter on that. I'm going to calculate, enter on that. Okay. And now we'll look a little bit down here. It says minimum of X is 10. Okay, so 10. Quartile 1 is 25. Cursor down, median is 30. Quartile 3 is 40. and max is 50. And again, you have a ruler and it saves you in erasing. So here, that's pretty straight. Then here, pretty good. And then below, cross, and then above, cross, pretty good. And then vertically, vertically, vertically. Okay. All right. So, give you a couple minutes to get caught up on that. So, turn over, we're looking at box plots with outliers. What does that mean? Well, sometimes data sets include values that do not seem to fit with the rest of the data because they are too low or too high in comparison with the other data values. These are called outliers. So data for another class set of marks is shown below. If you take a look closely at this, compared to the first one, some of the data values are the same, okay, but the lower ones in the first row, a little bit different, okay, and especially the first one. So it says determine the lower extreme, upper, median for the data. So again, I'm not going to put it in my calculator because they are in order. So remember our same number of data values, so it was 35, so our median is the 18th. And then this is our first quartile, this is our third quartile, and we've got our lower extreme and our upper extreme. So 25, 62, 71, 80, and 94. Okay, so these are all the same as the first example that we did. Okay, it's the lower extreme that's different. So one mark, 25, seems to stand out when compared to the others. To determine whether we would call 25 an outlier, we use the following information. So there's a formula to use in order to know if it's technically an outlier. So what is the formula? We have to calculate what's called the interquartile range. Okay, that's the difference between these two. So we subtract those. So 80 minus 62 is 18. So it's basically the difference from one part, the start of the box and the end of the box, if you were to do a box and whisker. So that's 18. So if a data value is less than the lower quartile minus 1.5 times 18, or greater than the upper quartile plus 1.5 times 18, then the value is an outlier. So basically you want to multiply your interquartile range by 1.5. So that would be 24. So it's giving, basically it's saying, okay, if the whiskers are 1.5 times as long as the length of the box, okay, then that's reasonable. But anything more than that will be what's called an outlier. So the lower quartile was 62 minus 24, and what is that? 58 equals 38. Okay. Oh, did I just do something wrong? Oh, I did, didn't I? It's not 24. 18 plus 9 is 27. 27. So 62 minus 27. Yeah, someone just put that in the notes. Yeah, thank you. I made a mistake there. So that's 55, that's 35. And then 80 plus 35. Oh no, sorry, 80 plus 27 is 107. Well, really that wouldn't happen unless you were allowed bonus marks or something on a test. But that would be the upper quartile plus that sort of outlier factor. So is 25 an outlier? So yeah, because yes, as it is smaller than 35. Okay, so it's basically, here's your, let's say this is your original box and whisker, okay? And so once this would end up being our lower quartile 62, and then we want to make sure that when we subtract that 27, we get 35, and we want to see if there's a value that's outside of that, okay? And so we'll look at that in a sec. That's how you calculate it. Are there any other outliers? No. There's only one that's less than 35, and there are none that are greater than 107. Okay, so no. No, it just means, as it says there, it does not seem to fit with the rest of the data because it's too low or too high. It's still someone's mark, but everyone else did way better on this test. Like a lot better. Or maybe the test score was really quite low for everyone, but there was one person that got 100%. That might be an outlier depending on the calculations. So it's one thing, one data value that just doesn't fit with all the rest. Because take a look, if I join this one up here, that whisker is huge compared to the rest. Okay? So you don't know for sure if it's an outlier until you do the calculations. So the box plot indicating the outlier shown below, note that the outlier is indicated with an asterisk and that the left-sided whisker is extended only to the smallest value that is not an outlier. So we basically, if you did this, like this, then check to see if it's an outlier. And if it is, you make this a star and you delete the line in between that till the first value, until the next data value. So the next one was 52 in your chart. Right, so then it's 52. Okay. So that's something you will have to remember, is to check for an outlier. You take the interquartile range and multiply by 1.5, add it to quartile 3, and subtract it from quartile 1 to check. And then the last thing we want to do is use our calculator for this to actually draw a box plot. Again, are you really going to use your calculator that often to draw it? Not really, but it will check for outliers for you. So that might be a good thing. So what do you do for this? We do need to enter the data. So we go to Stat, Edit, and clear off the previous lists. Okay, and then we want to go to that data. Oh, sorry, there's a bug here. There, and enter it all in list 1. So it takes a few minutes to do that. So I'm going to do it from this. Okay, 35 data values. You might want to scroll back. You see that you only entered one digit. Maybe you know that you did something wrong. Looks pretty reasonable. I think I got them all in there. Okay, so we've done that. Then clear out of that, or quit out of that, and go to stat and calculate again. Okay. Oh, sorry. Yeah, we don't have to calculate anything actually. We're going to plot it. So quit out of that. Sorry. We want to go to stat plot. So second y equals is stat plot. And we're going to turn on, so enter on plot 1. And we want to turn it on. There's another way to turn it on as well, but this goes through all the properties. Yours might be set up a little bit differently. This one has all the types of graphs in one line. Some calculators have them on 2 lines. Doesn't really matter. So we want to turn that on, and we want to look for something that looks like a box and whisker. Okay. First, we're going to choose well, you actually have a choice here. So notice it's here you have a choice of 2 that look like a box and whisker. We're going to choose the second one there to start. Although they're saying the first one. Okay, we'll do what the notes say, just to do it the same. And then we'll try the other one as well. Okay, so enter on that. And then it changes some of the other information. So XList, L1, that's where we put all the data. Frequency, there's one of each. So probably that's shown in there, right? If not, put a 1. Or if it doesn't prompt you in an older version, you don't need to worry. The type of marking, I like the first one, it's a bit bigger. I get to choose a color, it doesn't matter if you don't do colors or not. So in this case, you do have to check your window. So it says ZoomStat will do it for you. But I kind of like to do it myself. So I go to Window, okay? So your X-min has to be at least as low as your lowest value. So the lowest value is 25. In this case, all of these box plots that we did for marks, we went from 0 to 100. So I'm going to do the same. Okay. Scale, does it really matter? Not really. You can go up by 10s if you want. I think they went up by 5s, but it doesn't really matter. The Y values, it doesn't matter. We'll see if you change them what it looks like. It's just going to plot it higher or lower. So let's leave it as is and press graph. Oh, and you know what? I still have something graphed on there from yesterday. So I'm going to go to Y equals, once it's finished. Y equals, oh, it's still chugging away. Because I forgot to clear off things from yesterday. So now if I graph, I won't get everything. So that first box and whisker gives us our outlier. Okay? If you press trace, it will go to the first value in your plot. And if you cursor to the right, it'll go to your quartile 1, median, quartile 3, max, and then that. Okay, notice, yeah, you can flip between all of them. Okay, so if you wanted to get those values and just that, you could actually plot it and not do your one variable stats, and it would give you all those. Okay, now if we did the other type of stat plot that looks like a box and whisker, so enter on that, cursor, and the second one, now grab that. That's the one that doesn't identify the outlier. Okay, so if I go trace on this, there's your median, quartile 1, and your lower, etc. Okay, so the second type of box plot in there does not show the outlier. Okay, so again, this is a way of checking. If I ask you on a test, are there any outliers, you could enter it, do the first version of the box plot, and do it without calculating by hand. So your calculator can help you a little bit. Okay, so that's it for the lesson.